At the heart of our galaxy, 26,000 light-years away, lies a monster, a point of no return, a place where time itself slows to a crawl. This is a black hole, not empty space, but the densest object in the universe, a stellar corpse so massive that even light, the fastest thing in existence, cannot escape its grip. Watch how space bends around it. The light from distant stars doesn't travel in straight lines here. It curves, it spirals, it dances at the edge of oblivion. Einstein predicted this over a century ago. He called it gravitational lensing. We call it terrifying. How was this built? What you're seeing isn't a video. It's a real-time simulation, rendered entirely on your graphics card using mathematics derived from Einstein's general relativity. Every pixel on screen represents a ray of light, traced backwards from your eye into the scene. Near the black hole, we calculate how gravity bends each ray using the Schwarzschild metric, the same equations physicists use to model real black holes. The glowing disk? That's the accretion disk, superheated matter spiraling inward at nearly the speed of light. We simulate it using layers of procedural noise, rotating at different speeds to create that turbulent, fiery appearance. The colors come from a temperature gradient texture, creating that dusty, turbulent glow. The brightest regions near the center represent matter accelerating to near light speed, superheated to millions of degrees. Look carefully at the edge. You can see stars appearing above the black hole that are actually behind it. Light is bending so severely it wraps around, letting us see the back of the universe. This is the photon sphere, where light itself enters unstable orbit. That perfect dark circle, the event horizon. In our simulation, any ray that crosses this boundary simply stops, returns black, just like reality. Once inside, nothing escapes. Not light, not information, not time. 300 rays traced per pixel, thousands of calculations per frame, all running 60 times per second. Mathematics becoming vision, Einstein's dreams rendered in silicon. This is where physics breaks down, where our understanding ends, and perhaps where new universes begin. If you enjoyed this journey to the edge of space-time, hit that like button and subscribe for more physics visualizations and coding deep dives. Want to build your own black hole? I've put together a beginner-friendly tutorial where you can create a 2D version. Check the link in the description below to get started, and drop a comment. What should we visualize next? Wormholes? Neutron stars? The Big Bang itself? See you in the next one.